So whenever I give workshops or when I go to conferences, I often get a lot of questions from teachers about how to make inquiry manageable and some of the problems with implementing inquiry. So my friend Janet here and I are just going to go through some of those questions that I commonly get asked and work on solutions and ways that we can fix those problems. So Janet, if you've got a few questions, I'd love to go through them with you.
Okay, Jamie. Well, I like the inquiry approach in theory, but practically speaking, I just don't know if I have the time for it. I mean, I can hardly get through the curriculum as it is.
So let me break that down a little bit. What about the curriculum is difficult to get through? What's the time constraint?
Well, sometimes I find no matter how well I plan things out, I find once in a while I have to backtrack when I can see that students really aren't grasping a concept, so I have to spend a little more time than I had originally planned.
So that does happen, and obviously we have to reteach, right? I mean, that happens, forgetting happens, kids don't always get it the first time. But one of the things that inquiry can actually do is it actually allows you to differentiate instruction a little bit. So you can have, and all the groups are going to be working on some task, and you can focus on the kids that you know are having a little bit of a harder time, and you can spend a little bit more time with those kids, bringing them up and giving them more information. And the kids that already have it, they can go off and do whatever experiment they need to. And you can go to those groups and even give them more interesting challenges. You can give them stuff that like, hey, you finished this lab early, try, what if you used zinc instead of magnesium? Would it still work? Try it out. And so you can let the groups that are ready to jump ahead, and then you can focus your personalized attention a little bit more on the kids that need help. And that way, maybe you don't have to reteach the whole class this lesson that maybe 15% need help with and the other 60% maybe have it and the rest are somewhere in the middle. You can focus your interventions more on the kids that really need the help. And the other thing is we can think about inquiry as sort of like an investment. If you put the investment in early on, getting kids to think and think really well, and they're really working through the concepts on their own, they're probably going to understand it a little bit better. And a lot of the reteaching is like, I covered it in class and not everyone got it. But if kids are developing it for themselves and they're getting teacher help along the way, you might at the end of the course need to spend a lot less time reteaching, and you've already front loaded it with a little bit of investment that pays off later on in the year.
Okay, so I get that we want students to think more for themselves, but we all know that we have some students that are just going to search the internet, or they're going to talk to their older friends or siblings, and they're just going to copy what someone else has already done.
Yeah, and that's going to happen. Actually, that's what science does anyway, right? In major research, people aren't inventing an entire procedure all for themselves. They're looking at what already has been done, and they're learning how to modify that procedure for what they're doing. So when I worked in research after undergrad, we were constantly scouring the literature and adapting somebody else's procedure. So if kids go to the internet and they find a procedure that's similar and they make a new procedure based on that one, I don't think that there's a problem with that. They've searched and consulted references and came back and still made it their own. But the nice thing about inquiry is you can keep changing the question. So if you use the question one year, you can change the question for next year. Or we've got a whole periodic table to pick from. You can often substitute one chemical for another, or one compound or one solution. And so you can keep varying the parameters. You can change which labs you make inquiry every year so that kids are not just getting the exact same version. But if you're going even more into the open inquiry method, kids are developing their own questions. And so they're not going to copy last year's question if they're really legitimately making their own. But a few of the fail-safes I put in place in my class, I make sure that if they're designing a procedure, they're doing it in front of me. So I devote class period time and they just work with their partners and they brainstorm. They bring their drafts to me. I give them corrections or things to think about. They take it back and they bring me the second iteration and the third iteration. And we're doing all of that in class. And if they're right in front of you, depending on the cell phone policy in your school, they're probably not pulling up the internet and looking for it. But if you're also giving them a novel question that there isn't already a procedure for, then there's not really much they can do to find another one elsewhere. But adapting a previous procedure and making it your own, in my mind, is not a bad practice for kids to learn. Now, completely copying what somebody did, yeah, we want to avoid that. And you can do that with some controls. And the same thing happens with a regular lab report. Kids can talk to kids from last year and get their lab report, regardless if it's inquiry or if it's a teacher-directed lab. So either way, you still have to put all the fail-safes in place to ensure that kids are really thinking for themselves. Because that's the point of inquiry, to make kids think more.
Well, with students all designing their own procedures, how can you ensure that what they come up with is safe?
Yeah, so safety is a primary concern, and I don't make the most dangerous lab with the most hazardous chemicals and 27 steps be the one, I'm gonna make that one inquiry. I mean, make it easy on yourself, make it easy on your kids. Pick the labs that are safe, like the kinetics and Clorox lab that I have. Green food coloring and bleach can go down the drain as long as they're rinsed with extra water. These are non-hazardous things that are very easy to control the safety around. Don't pick the very dangerous compounds. And you as a teacher also have veto power. So if a kid suggests something that's unsafe, you can say, no, we're not going to do that experiment. It's not safe. No, you can't test acid concentration by pouring it into your partner's eyes. I mean, or you can also say, we don't have the equipment to conduct this experiment, try it a different way. And the iteration of going back and trying again is a fine thing for kids to do. But make sure that you put the safety in. If you have a written procedure, write your own safety notes on the kids' paper before you hand it back to them so that you can make sure that they're handling safety appropriately. Plus, you're going to be circulating throughout the lab and you have your eyes open. So if kids are doing something that's not looking safe, you can stop them and ask them what they're doing before they go too much further.
Do you really have time to check all the group's procedures?
So this goes back to how many groups do you want to put into a room and how much time do you give. So if you give a little bit of lead time, you can get more procedures edited. And if you make your class groups bigger, then you have fewer procedures you have to check. And you can also limit how many procedural steps they have to do. You can give them the first 3 and say, okay, give me the rest of the thing. So get them started in one direction or narrow the focus. Give them a certain number of chemicals or a list of chemicals they can pick from, a list of compounds, and say you can only use this to do this lab. That's another way to control the safety. And then you can make sure that they're picking from fewer choices and just narrowing the focus of the lab a little bit. So depending on your own classroom, you're obviously going to make adaptations to make it successful for your room.
Now with each group doing something a little bit different, and obviously some are going to be a little more advanced than others, how do you fairly assess all your groups?
So this is where a lot of premeditation has to happen. I mean, anytime I do an inquiry experiment, I usually give my kids some kind of a rubric of like, either if they're going to do an in-class presentation, here are the stuff you need to cover in your presentation, or if it's a lab report, I give them a little half-page rubric of the pieces of the lab that have to be there. And that's good for them and me because then I'm just going on a checklist for the rubric, and it's not like I have to write individual comments. Well, how many points is that worth? I've already thought about the points and where they're going to be. And as long as the kids have all the pieces there and they've done them satisfactorily, they've put good explanations in, they've made conclusions from data, it's fine if the kids that do the super advanced, amazing procedure and the kids that do the very basic, simple procedure, if they all get good results and they all make good conclusions, that's all we're looking for. And if kids are ready to go further, usually the thrill of being able to try something different or try something for your own is kind of a reward into itself. And that's where you can use, as a teacher, for the kids that are really ready to jump ahead, you can really give them some praise for the fact that like, oh wow, you did that procedure really well. Here, try it this way, see if you have something interesting. And you can point them in the direction of really fascinating stuff. And they're like, oh, this is so cool. And they don't really care that somebody else who did an easier procedure still got the same grade because they got to do something really cool that another group didn't get to do. But making sure you've clearly established, here's what I'm looking for, so that kids can deliver the items and pieces of knowledge that you want them to bring forward.
Yeah, how can I make sure I get the level of precision that I want if I'm not directing that procedure step by step?
So one thing I've noticed with very detailed, I give my kids some labs that are very detailed to get a lot of precision, and sometimes kids get so lost in that procedure that they kind of forget what they're doing, like they forgot why I'm doing this lab in the first place. And so even if you give them a lot of detail, it doesn't always result in better precision. I still get kids who get very huge errors on very detailed procedures versus student developed ones. And so you can always ask a question at the end of the experiment. If you do an inquiry experiment and they don't have 3 sig figs, then make one of their analysis questions. How would you get 3 significant figures? What would you have to do to this experiment to ensure you got 3 significant figures? Or give them choices in glassware that have different precision. And then they can use those tools and say, oh, this one's going to give me more precision, so I'm going to use that one. And I think that actually, honestly, gets kids to understand precision in science better than just saying, make sure you have 3 sig figs, because they'll do whatever they have to do in the calculations and report 3 sig figs, regardless if they were justified from their data. But making sure that they have real choices, and at the end you're doing a lot of dialogue with the kids or as a class talking about how would we up the precision level of this lab if it's not a high precision lab. But again, not every lab's going to be inquiry. Pick the ones that you don't need necessarily the highest precision, but if kids have already done high precision labs, you can say to them, hey, this procedure doesn't quite have enough precision in it. Go back and bring me back one that can give me 3 sig figs. And make them come back and give you a second draft and improve the one they have. And that's going to make them better scientists, but it's going to make them think more carefully about what precision really means.
How do you handle it when students actually develop some misconceptions by doing inquiry, going on their own?
Yeah, so kids can get misconceptions, I think, no matter what we do. There are times I give the best explanation I can possibly come up with a concept, and kids still get the wrong idea, regardless if it's inquiry or if I'm telling them. I mean, kids, and usually a misconception is really good logic. Kids are thinking very carefully, and they're just taking information they have and logically coming to an answer that doesn't happen to be right. And so if you actually ask the kids, like, how did you get there? If you hear something that just sounds wrong, like, what makes you say that? Why do you think it's that way? I just want to know what you're thinking. And if they can articulate, like, well, this happens and then therefore that happens, it might just be that the first 3 steps were perfectly right, and they just made one little error in that last bit. Oh, okay, that doesn't apply to this case because we've got some other force that's keeping it from working out that way. And so the more you can do to dialogue, misconceptions are something teachers always have to pay attention to, and I think you might actually get more insight into their misconceptions when they're actually articulating the knowledge for themselves. So if they have to design their own procedure and they bring you something that makes no sense, it's very clear that they don't understand what's going on. You get that opportunity to say, hey, let me explain a few things to you because I'm not quite sure that you've got everything under your belt ready to go into this place yet. So it can help with your formative assessment too, because it gives you an opportunity to open a conversation with a kid rather than just saying you got the wrong answer. It really is saying, hey, tell me what you're thinking because I want to give you a little bit of help here. And it just gives you more ability while other kids are working on something else to offer independent help to certain groups of kids.
Well, thanks. That's really been very helpful.
It's been great talking to you.